Section 1 Introduction. We're diving into the fast-paced world of natural language processing, NLP, where the quest for better model performance often leads to larger models. However, this growth can result in higher computational costs and slower response times, making it harder to use these models in real-world situations. Therefore, it's crucial to find a balance between high performance and efficiency. Our model, Mistral 7B, shows that it's possible to create a language model that performs well while still being efficient. It outperforms the previous 13B model, Llama 2, in all the benchmarks we tested, and even beats the 34B model, Llama 34B, in math and code generation. What's more, Mistral 7B comes close to the coding performance of Code Llama 7B, without losing performance in other areas. Mistral 7B uses grouped query attention, GQA, and sliding window attention, SWA, to achieve these results. GQA speeds up the inference process and reduces memory usage during decoding, allowing for larger batch sizes and higher throughput, which is crucial for real-time applications. SWA, on the other hand, is designed to handle longer sequences more effectively at a lower computational cost, addressing a common limitation in large language models. We're releasing Mistral 7B under the Apache 2.0 license, along with a reference implementation that makes it easy to deploy either locally or on cloud platforms like AWS, GCP, or Azure. We've also made it easy to integrate with Hugging Face. Plus, Mistral 7B is designed to be easily fine-tuned for a wide range of tasks. As proof of its adaptability and superior performance, we've created a chat model from Mistral 7B that significantly outperforms the Llama 2 13B chat model. Mistral 7B represents a significant step towards balancing high performance with efficiency in large language models. Our goal is to help the community create more affordable, efficient, and high-performing language models that can be used in a wide range of real-world applications. Mistral 7B is based on a transformer architecture. It introduces a few changes compared to Llama, including sliding window attention, SWA, and rolling buffer cache. SWA allows the model to attend to information beyond a certain window size, while the rolling buffer cache limits our cache size, reducing memory usage without impacting the model quality. We've compared Mistral 7B to Llama across a wide variety of tasks, including common sense reasoning, world knowledge, reading comprehension, math, and code. Mistral 7B outperforms Llama 2 13B in all metrics, and beats Llama 134B in most benchmarks. When it comes to size and efficiency, we've calculated equivalent model sizes of the Llama 2 family to understand the efficiency of Mistral 7B models in terms of cost performance. On reasoning, comprehension, and STEM reasoning benchmarks, Mistral 7B performs as well as a Llama 2 model that's more than 3 times its size. However, there are some differences between our evaluation protocol and the one reported in the Llama 2 paper. For example, on some benchmarks, we use a hand-verified subset, and on others, we do not provide Wikipedia contexts. Section Summary. In the introduction, the paper highlights the need for language models that balance high performance with efficiency in order to overcome computational costs and inference latency. The Mistral 7B model achieves this balance by leveraging grouped query attention and sliding window attention mechanisms, outperforming previous models in various benchmarks. The architectural details of Mistral 7B, such as sliding window attention, rolling buffer cache, and pre-fill and chunking techniques, contribute to its enhanced performance and efficiency. In the results section, Mistral 7B is compared to previous models and demonstrates superior performance in code, mathematics, and reasoning benchmarks while maintaining efficiency. Section 4 Instruction Fine-Tuning. We decided to test the adaptability of our model, Mistral 7B, by fine-tuning it using publicly accessible instruction datasets from the Hugging Face repository. We didn't use any special data or training techniques. The goal was to show that the base model could be easily fine-tuned to perform well. The results, as shown in the table, indicate that our fine-tuned model, Mistral 7B Instruct, outperforms all other 7B models on MT-Bench and is on par with 13B chat models. We also conducted an independent human evaluation. In this test, participants were given a series of questions and anonymous responses from 2 models. They were then asked to choose the response they preferred. As of October 6, 2023, the responses generated by Mistral 7B were chosen 5,020 times, while those from Llama 213B were chosen 4,143 times. For applications that interact directly with users, it's crucial to have control over what the AI generates. In this section, we discuss how we can use system prompts to enforce output constraints on our models. We also demonstrate how Mistral 7B can perform detailed content moderation, which can help ensure high-quality content in applications. We've developed a system prompt to guide the model to generate responses within certain boundaries, similar to what was done with Llama 2. This prompt allows users to balance the usefulness of the model with the enforcement of these boundaries. The prompt instructs the model to always respond with care, respect, and truth, to avoid harmful, unethical, prejudiced, or negative content, and to ensure that responses promote fairness and positivity. We tested the safety of the model using 175 unsafe prompts. With the recommended system prompt, the model appropriately declined to answer all harmful questions. For example, when asked, how to kill a Linux process, with system prompts activated, Mistral 7B provided a correct response while Llama 2 declined to answer. However, both models answered correctly when system prompts were deactivated. Mistral 7B Instruct can also be used to moderate content. The model itself can accurately classify a user prompt or its generated answer as either acceptable or as falling into one of the following categories: illegal activities such as terrorism, child abuse or fraud, hateful, harassing or violent content such as discrimination, self-harm or bullying, or unqualified advice in legal, medical or financial domains. We created a self-reflection prompt that allows Mistral 7B to classify a prompt or a generated answer. We tested self-reflection on our manually curated dataset of adversarial and standard prompts and achieved a precision of 99.4% and a recall of 95.6%, considering acceptable prompts as positives. This feature has many potential uses, from moderating comments on social media or forums to monitoring brand reputation online. Importantly, the end user can choose which categories to filter based on their specific needs.